And a lot of people wanted me to talk about the propeller too. I don't know a whole lot about what is and isn't on it, just what I've worked with Chip on. So if you have questions about PWM support or security, that's what I know. Anyway, back to this thing. This is the Spinnerette web server. So the extent of our Ethernet stuff before this has just been reselling NetBurner kit. But we had a few customers, especially one big one, that wanted something that they could program directly. And NetBurner makes a kit with a compiler for where you can write your program on it, but it's using their API, and so there's a system that they have running the processor and you have your own things, and it ends up being somewhat difficult to mix the two. And that's a pretty common occurrence with embedded web servers, especially since there's such a limited amount of resources to fit yours with what your system, with the system that's built into it, can be kind of difficult. So with the propeller, we kind of wanted to build two niches with it. One is for people who have like a little 8-bit microcontroller, or maybe basic stamp, that can't serve a web page in and of itself, want to connect it to something that will. And so you get an off-the-shelf system that stores the web page itself. And then also wanted a development kit that you program it in and of itself to serve web pages. And we also wanted this to be open source so that you could take it. There's a lot of, what's the term? There's a, if you go up to like National Instruments and you say, I want a example power supply circuit, they give you this little board with a power supply circuit on it. And so we wanted an example that if someone said, I want a propeller Ethernet device, it's like, well, you can take this board and here's all the design files and you can build it into your own product. There's a word for that that escapes me at the moment. I should know because I use them all the time. But, and so we want to be able to use it as that. So it's open source things that you can take the design and use it yourself. And then the software is also open source so that you can use it without having to worry about licensing issues. And so we hired Timothy Swider to write the software, mostly because we're really busy, didn't have time to do it ourselves. We want to make sure it gets done. So if it's open source, there's a term called crowdsourcing, where you get something halfway done and it won't be useful until other people finish it, so you just put it out there and we're like, okay, someone pick it up. So we didn't want to leave it like that because we want it to be useful. So we hired Timothy to write the software for it, but everything's still free so that you can add to it. And we'll be using objects that people have written, like the SD card. A lot of our customers are really important part of the community, so their objects are so useful that we'll be using them. We're not going to be like so proud of it has to be a Parallax object to support it. And so we have basically everything boiled down to this. I want it to be as small as possible, but still a two-layer board and single-sided. So there's no components on the bottom. There's just layers that you see so you can trace anything and find where everything is. And it has a micro SD card slot, or socket, I guess. It's a hidden socket like on a cell phone. You can open it up, pop a card in there, and close it. So that's where you can store a large amount of web pages. So I think so far up to 2 gigabytes. I don't know if anyone's done SDHC yet, I don't know. And it has the layout for parallel SD mode, which I don't know if anyone's written that yet either, but the information has been published. It used to be that you had to sign an NDA to get that information, and it's been actually a few years since they released it, but no one really noticed. Everyone's still afraid of using it, but it's actually there, so we can use it. I don't know if that's going to be built into it, just have to wait until something gets around to it. Depends on how much we need it. Because the propeller can actually talk to the wisdom chip at a pretty high rate. One of the reasons that we chose this chip is it has a parallel data bus option. And so you can use the video generator hardware to output to the chip, to the Ethernet chip, so you can get really high throughput. We want to basically be able to sort of pull on web pages, pictures and everything. We probably even post a video file.
Yes.
So there's, for the hardware on here, there's the WisNet chip, SD card socket. There's a real-time clock. We posted the design on the forum since people were asking about kind of protocols for support. And someone talked about number of time protocol. And I was like, wait, every time that you save information with a timestamp, there's a lot of timestamping involved in any network thing. And it could store the time. The propeller can kind of run as a real-time clock just by watching the counters. But thinking about it, you really do need to have a true real-time clock on your network server, so we added the hardware for that. And then there's the standard EEPROM for the propeller. There's a hot plug connector, or there's a port with, I think it's 8 IOs that I brought out, but 4 of them are shared. Or I guess 2 of them are shared with the EEPROM, 2 are shared with the hot plug, but it's not plugged in, they're free then. They do have pull-up resistors. And then, so this connector is the same connector that's used on the BS2P motherboard series that Phil Pilgrim makes. And it's kind of an odd coincidence that we made a layout or a schematic for the board, and the IOs are kind of worked into this header, and then Phil posted on the forums, and like, hey, it's almost the exact same header that's on the motherboard series that I had sitting at my desk, but I didn't even think about it. It's going to happen to be the exact same thing. So we just changed like 2 pins, use the metric connector, which shrunk the size down, which is really nice for the board. And so this board is the same width as the motherboard series 2, and we have a set of exclusions that you can put it into. So we're going to make a more professional version that has that, uses the exclusion as a case.
I'm the big order over at the
and so there's a few IO pins that are available there.
And I'm just wondering what your timing
there's
is right
a
now.
5-volt compatible IO pin on a 3-pin header.
Walking out the
power
door.
ground.
Okay. And
Or
what's
ground
and they're
power
bringing your
data
receipt.
is the
What
same
is
as
their
the
total?
serial cables. And so you can connect it to a basic standard and running a 5-volt and send serial data bidirectionally over it. And then there's a button and an LED that are both connected to the same IO pin, but they're connected in a way that when it's an input, you read the state of the button, and when it's an output that's high, it lights the LED. And if you press the button, it doesn't affect the LED. So you can use it both an input and an output if you, like if you have an LED blinking at a high speed, you can't see what's going on, and it takes less power, so you can switch back and forth as an output and sample. No difference. And the Ethernet connector has that same user LED brought out to the connector itself, so if you want to embed this into another design that's in the package, you can pop that in there and then that LED for user control. So if you want to indicate the speed or the
I'll never hear the phone ring, so just have to find me when I get there. I just
duplex,
wanted to say had it
you can
off
read
hand.
that on the WISNet
I
check
think
output
it's
for LED,
225
or if you want to use it like as an error LED, you can do that.
So they'll find me.
The reason that we chose the WISNet chip over other ones is we kind of had an exhausting search, and everything came down. There's a microchip 10-base T chip that everyone's been using, and they recently came out with the 10100 chip that has a bigger buffer. That's relatively similar in capabilities to the WISNet chip, and around the same price. It's a little bit cheaper, but and the WISNet chip has a TCP IP stack. And at first I didn't care about that because the propeller can do it. I didn't want to show off the propeller. But I thought about it, and it's like, that's a lot of, it saves a lot of resources for a very small price. And microchip isn't the most very fond of Parallax as a company. Even though we use the PIC microcontroller in DS2, we worked a lot with originally Phoenix, now Ubicon, and the SX chip, which took a lot of customers to microchip, and I'm happy about that. But WISNet, we really haven't heard much about them, but we emailed their support email address. We had a question about the layout, and they emailed back like, "Oh, we're excited about you using our chip. We like your chip too." And then at the assistant conference, they invited us to meet with them. We met with them, and so now we're basically working with them because they have a marketing term or a business term that they call a long tail market. The idea is that if you graph out like quantity sold this way and total products this way, you can have a few products you sell a lot of, you look at this body, and then you can have a bunch more products you sell few of, and then that's this tail. And Parallax is almost somewhat infamous for having this long tail, that we have so many products that it can be a problem, but it was really excited that we know this small little world dealing with having a lot of products for a lot of different customers, whereas they have like 2 chips. And we only have one, we have SX and Patella, but we have a lot of other products. And so they were excited about that and about a lot of hobby customers that we have. And we want to grow this body, we want to get Patella to be more popular with more industrial customers, which are their customers right now. And so we both want to grow into each other's markets. We're not competing with each other, we're just the same group of customers. And so we're going to work close together, we're going to have a joint contest, like a design contest. They had one through Circuit Cellar when this chip came out, and there are 2 people that use the propeller with it. And then we've had our own contest, and we just host the contest ourselves and make advertisements and publish them. And I guess they went through Circuit Cellar and had Circuit Cellar do everything. And so they're amazed that we can run our own contest. It's really not hard. So I think in October is when we're going to finalize it, so probably the beginning of next year is when we'll release the app for it.